We are live. चेक कर लेता हूँ एक बार. चेक बोल ले.
Check, 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 check.
चेक बोल ले.
Check, 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 check.
बस आ रही है.
Mm.
बस आ रही है. Done. All the checks are complete. We can start. Oh, finally. So, welcome back. How we doing?
We're doing great. We're doing great. So today, I think we are gonna focus on time code and time samples.
Yeah.
Yesterday,
Do you just want to give a recap of what you have done till now?
yeah, I think till now we have completed stage, prems, and property. And yesterday we focused on relationships specifically, how relationships are used for different prems, and how can you use relationship to create linkage between different kind of prems and the properties that you have. Uh, I think that will cover it, right? Or do you want me to add something else? Or if I have missed something?
Yeah, so basically, what we have completed till now is the basics of setting up a stage in OpenUSD, what are prims and how do they work in scene description, what are the properties those prims have, and in those properties, what are attributes and what are relationships, how they differ from each other. Attributes are more of, about the prims or like maybe the color, the shade, the lighting angles they reflect off, stuff like that. And relationships are basically used to establish the linkage between those prims, maybe um, stuff like that. Maybe to group different prims together in a you know in a single group which behaves like oneself. For example, a wheel and a windshield and a wheel can be grouped under car. So we're gonna basically use a relationship to group those prims inside that another prim hierarchically. So and today now we're gonna just focus on time codes and time samples. So I think we can get started.
Yeah.
Okay, so time codes and time samples. In this lesson, time code and time samples show us how to set up animation in a stage using OpenUSD. So in this lesson, we will basically set start and end time codes for a stage. Okay. Learn how to set start and end time code metadata for a USD stage, establishing a timeline that forms the foundation for animated scenes. Okay. It's now over here we're gonna set time samples on attributes. Okay. So we're gonna basically set time samples on attributes. Gain the skills to set the time samples on individual attributes, allowing us to animate specific properties of prims over time. Okay, so basically, I think we're gonna set particular values as time samples on different attributes, and we're gonna let OpenUSD animate the properties, or let yeah, it's basically on animate the specific properties of prims over time on that stage. So over here, time code. What does it say? One sec. Time code is a unitless point in time, like a frame with units derived from the stage. Unitless point in time. Okay. Do you wanna add something onto this? Or
No, I think let's like we can go ahead and see what it says now.
okay, and then Time sample refers to individual time varying attribute values. Oh my god, fast. Refers to individual time varying attribute values in USD. Time sample refers to individual time varying attribute. What does that mean?
So I think I would say that okay, on each and every timestamp, the attribute value might change. You know, so for
Mm-hmm.
example, we have a clip of 5 seconds, and that clip is trying to render a ball, and that ball is trying to change a color from red to blue.
Mm-hmm.
So let's say on the first frame, in the first 5 seconds or 4 seconds, the attribute values are set to maybe the size of the sphere is 4, and on the 10th second the size of the sphere is 8. So in that scenario we can see that okay, there is some kind of a change in uh, dimensions or something of the sphere, and that's how we would render it. I think that's what it is trying to say.
Okay. Attributes can have multiple time samples. Okay, one attribute can have multiple time samples, mapping time codes to data type values for animation over time. Okay.
So an attribute can have multiple time samples. So yeah, it means that okay, an attribute uh, can be attached onto different time points. For example, I would say if you keep the attribute same,
Mm-hmm.
let's say you have uh, wait, this is an attribute, like this is an eBay card, and this is an attribute of color or something, right?
Mm-hmm.
And this attribute, so on the first
Wait,
frame
wait, wait. 1 second. I'm gonna. Yeah. Now.
okay, so on the first frame the attribute is okay, we need to show the card, right?
Mm-hmm.
And then on a second frame there are no attributes.
Uh-huh.
So what is it now? It's hidden,
Yeah, it's hidden.
right? And on the fifth frame, the attribute you can attach the same attributes. Now you can
Mm-hmm.
see that the frame is rendering the
Mm-hmm.
same point. So I think we can map the same attribute to multiple time frames over the
Mm-hmm.
timeline, and in
Okay.
that scenario, that's how we can do the animation rather than that's what it's trying to say over there. I would
Mm-hmm.
say.
Okay. Yeah, I think this is we're gonna get more clarity once we
Yeah.
read. Okay, what's the third point it's saying? Time code is, oh, okay. Never mind. In OpenUSD, time code and time samples. So time code represents a point in time for querying or authoring time varying data in USD. Time code represents a point. Okay. And time sample is a time value pair that defines an attribute's value at a specific time. Okay, so it's like a dictionary where it's defining the attribute's value with the key being the time, like the time sample being,
Yes, that's what I
yeah,
said, right? That's what I
yeah,
said. Like basically, you are on a scale of 1 to 10. You're
yeah.
gonna map this attribute. Let's say this is an attribute
Mm-hmm.
to that time frame, and then you can move that attribute at anywhere.
Mm-hmm.
So you can map the whole time sample onto the same attribute,
Mm-hmm.
and it's not gonna change. But you can change other attribute. Let's say there is this card that is gonna come up like this
Mm-hmm.
on some frame, and then it's
Mm-hmm.
gonna go down, and that is
Mm-hmm.
what basically the attribute would be at that point on a different time frame.
Okay, a
So
time sample, yeah. A time
yeah.
sample is a time value pair that defines an attribute's value at a specific time. Cool. So in OpenUSD, time code and time sample are two important concepts that enable us to work with animation and simulations in USD. Okay, time code is a point in time with no unit assigned to it. Time code is a point in time with no unit assigned to it.
So
Point
time
in
because
time.
time
It's
because
just a
time
point in
is
time.
yeah, like time is relative.
Hmm.
Einstein strikes again.
Fuck. You can think of these as frames whose units are derived from the stage. You can think of these frames whose units are derived from
The
okay.
stage.
Complicated, but the God is with us. Think of time codes as tick marks on a ruler that doesn't have inches or centimeters written on it. Okay, so basically, imagine you have a ruler with 60 lines, little lines, ticks, but no labels. The ticks time code. These are just positions. Line 30 is exactly halfway. You don't know that's 30 seconds, 30 frames, or 30 minutes. Oh, okay. So it has no specific unit or like metric to
Hmm.
attach to it. Got it. Time samples refers to individual time varying values associated with an attribute in USD. Time samples refers to the individual time varying values. Okay, got it. I think I understood what this is. So basically, time codes are those tick marks on the frames, and then time samples refers to the individual time varying values. So like multiple tick marks for an associated attribute are gonna be called a time sample for
Yeah,
a individual. Yeah,
similar to like if you put effects in an iMovie, right? When you put the
yeah.
frame, and then in the timeline you can put maybe
Bro, have you
crossfade
used
effect.
Adobe Flash?
No, I have
Bro,
only
I
used iMovie.
I have done Adobe Flash animation classes when I was a kid.
My
And I
God.
think I remember what this is saying. So basically, in Adobe
Steve
Flash,
Jobs, is it you? Steve Jobs, is it you?
fuck you. So basically, what happens is if you define, like on a frame, if you define
Mm-hmm.
this like a circle, right?
Mm-hmm.
And then let's say this is on 1 second, like first second, right?
Mm-hmm.
And then on the second second, you define like the same thing you define as a square, like on the same frame. So there has to be some sort of thing. So like let this be the first frame, let this be the second frame, right?
Mm-hmm.
But for this circle to become into this square, there needs to be some sort of animation that needs to happen. So
That is what we call at the thing. That's where we will put attributes, right? Because the attributes are gonna change.
mhm.
I
Yeah,
think I would
attributes are
say.
gonna change. So it's gonna USD is gonna perform the animation on its own. We don't have to do anything. So this you're
Hmm.
gonna see a sphere like a circle becoming a square in real time.
Hmm.
That's what I studied in Adobe Flash.
Hmm.
But I should, yeah, I'll do that later. Okay. Time samples refers to individual time varying values associated with an attribute in USD. Okay. Each attribute can have a collection of time samples. Each attribute can have a collection of time samples, correct, that map time code to attributes data type values, correct. So one time code, so basically in this, in an attribute, sorry. So let this be the dictionary of that time sample. And over here, this is gonna be the time code, right?
Mm-hmm.
Over here. And this is going to be the attribute value, like what the attribute is at that point,
Mm-hmm.
right? And so this is going to be called a time sample as a whole,
Mm-hmm.
right? This is what it means, I guess. Mm, Okay. Attribute can have a collection of time samples that map time code to attributes data type values, allowing for animation over time. For a reminder of the purpose of attributes, please review introductory lesson. Okay. How does it work? In USD scene, the time code ordinates of all time samples are scaled to seconds based on time codes per second metadata value. Data about prims and properties that guides USD's behavior. Metadata is data about prims and properties that guides USD's behavior but is not renderable in content scene. Okay. Metadata value defined in the root layer. This allows flexibility in encoding time samples within a range and scale suitable for the application, while maintaining a robust mapping to real-world time for playback and decoding. Okay, this allows flexibility in encoding time samples. Time codes per second. Bro, do you understand this?
Time codes per second. Hover over it. What does it say? It's gonna say
Doesn't say
something, right?
anything. No.
No.
This says metadata. Oh God, God mode on. The analogy is a blank ruler. Ruler is the stage, the text. These are positions. 9:30 is exactly halfway, but you don't know that 30 seconds, 30 frames. The stage acts as the label. If you tell the stage each tick represents one frame at 30 frames per second, then time code 30 is equal to 1 second, time code 60 is equal to 2 seconds. Okay. So the stage and the time code are dynamic.
That,
Oh, it makes your animation scalable. If you animate a ball to bounce at time code 24, later you decide to change your project from 24 FPS to 60 FPS, time code stays at 24. You don't have to rewrite your animation. The stage simply calculates how fast playhead moves through those ticks. Yeah, see, this is what I was talking about over here with Adobe Flash.
mm-hmm.
That it basically recalculates how fast playhead moves through those ticks.
So what does time code per second means? Because I think it said that time sample or time code doesn't have a unit. Yes, it says the time code is a point in time with no
Yeah,
unit assigned to it.
exactly.
And then time code per second is like, okay, the frame is in per seconds. That's what it meant, right?
Where does it say time is in per
Oh,
second?
like it says time codes per second. This one, this variable.
Oh, this one? Wait, I have not
Yeah.
put that in as of right now. Wait. I was reading the earlier one. 1 second. Key terms in simple English: time code, location on the timeline,
Frame
frame
10. Yeah,
10.
that's what I said. Frame 10.
Yeah. The value at that location, at frame 10, the ball is 5 units high. Okay. Time sample is the value at that location.
Yes.
Oh, so basically this is gonna be value.
Yes, because it says that, right? It was a
Yeah.
dictionary key value pair.
Yeah, time code and
So
value.
time code is key and value we have.
Yeah. So basically this is gonna be a time sample where if this is 1 and the value is something over here like bounce or something, right, for a ball, and then 2 is something else. So basically this is gonna represent like a total time sample. Got it. But yeah. Okay, now let's see time codes per second. The speed limit set on stage that tells the computer how many takes happen in one real world second. Okay. Time codes per second over here just means like in 1 second how many ticks are gonna happen.
Hmm. In 1 second, and what is a tick? How these are just positions. Line 30 is exactly halfway, but you don't know if that's 30 seconds, 30 frames, or 30 minutes. The ruler, the stage act as a label. If you tell the stage each tick represents one frame. Oh, okay. So you can predefine how much. Okay, okay. Makes sense. Makes sense.
Hmm.
Then what is time code per second then? Oh, the speed limit set on stage
Bro,
that
the speed
tells the
limit,
computer.
yes. In 1 second, how many
How many
time codes
ticks?
are happening?
Oh, I see.
So in USDC, the time code ordinates of time samples are scaled to seconds based on the time codes per second metadata value defined in the root layer. Got it. So this is going to be defined in the root layer.
Hmm.
How many ticks are gonna take place in 1 second? Got it.
Hmm.
Everything is getting slowly defined in the root layer, bro. The root layer is gonna be really crazy.
Hmm. Yeah.
Everything like relationships, attributes, time samples.
Yeah. These are like the building blocks of US Open USD, right? So we
Yeah,
are just going step by step to see how we are gonna like align and put everything all together into a system
yeah.
to maybe create a render or something.
Hmm. Okay. So this allows flexibility in encoding time samples within a range and scale suitable for the application. This allows flexibility in encoding time samples within a range and scale suitable for the application while maintaining a robust mapping to real world time for playback and decoding. Okay. For example, if the root layer has time codes per second equal to 24, okay, a
That
time
means
code
it will
24,
have
24 ticks per second, like 24 time
24
codes per second.
per second. Okay, okay,
A
24
time code
time codes
value
per.
of 48 would correspond to 2 seconds. Yes. Okay. Time code value of 48 would correspond to 2 seconds.
Wait,
Got it.
how?
Bro, because
Uh,
48 divided by 2, 24 is 2. Bro,
but
it's
how does?
simple. Time codes per second.
Oh, okay, 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 okay,
So
okay.
let me explain it to you, you dumb motherfucker. Hmm. Okay, so in the time code per second is defined as 24, right? Which means in 1 second, in a one real world second, there are gonna be 24 ticks or time codes in 1 second. So for if a time code is 48, right? This means this is showing the data for 2 seconds, 2 real world seconds. Do you understand?
Yeah, I get it now. I get it because it says 24, so we do to 48 divided by 24,
Yeah.
and then we get two
Yeah.
seconds.
Would
Makes sense.
correspond to
Makes
two
sense.
second. For real
Makes
time
sense.
after a time code, zero. What is this? Of the real time after the time code zero. What does this mean? The last line.
Time code zero. Oh, time code zero. The first frame. Time code
Okay,
zero.
zero, one, and two.
Yes, zero, one, two. So time code zero would be like 2 seconds, right? That's how we define it. It says over there, time code 30 is 1 second, time code 60 is 2 seconds. So if we say time code zero, then wait, what?
Oh, wait, I think I understand. I think over here there is no like for zeroth second, like it's gonna be zero
Yeah,
and one. So like it's gonna be 24 for zero and one.
wait. For 24, it's gonna be you're saying zero.
Yeah,
Wait.
because at initially when there's no time, like when when no time has elapsed, then also time code
Mm-hmm.
is going to
It
be 24.
30 frames. So over here, 48 means 48 frames per second, right?
Wait, let me.
Yeah. It says 48 frame per second. So if you look at the some look into the Gemini one, it says that the stage act as the label, right? Each tick represents one frame at 30 frames per second, right? So at time zero, it would be the 48th frame, it would have 48 frames, right? Or it would have what?
Wait. Imagine you're looking at a long strip of movie film. The strip, the stage, this is your entire animation. Okay. The text, these are little individual frames printed on the film. The projector time codes per second. This is the speed of the machine that plays in the film. Yeah, the math. If the machine is set to swallow 24 frames every second, you want to know where you've reached for frame for number 48. Time code value 48. The machine eats first 24 frames, 1 second has passed. Machine eats next 24 frames, another one has passed. So, okay, why not just say 28, 2 seconds? We don't write 2 seconds because you might change the projector later if you decide the movie looks too choppy and change the speed to 48 frames per second. The frame
Oh,
48
okay.
is
But
now
but
one
but what does
second by
zero
using
mean? So, but
yeah, yeah, wait, I'm gonna ask.
bro, bro,
What?
my system froze again. The hell? What is? Ah, why the hell is my system freezing again? Again? I think I do have some services that are breaking my system up. I would have to take a look, man. I'm gonna restart again.
Yeah. Okay.
The hell?
Do it. Yo, guys. How's it going? Say hi in the chat. This is gonna be right back. So, over here, time samples are used to store varying data for attributes such as position, rotation, or material properties. When an attribute is valued at a specific time code, the value is linearly interpolated from the surrounding time samples, allowing for smooth animation playback. Ah, I see. Interpolation. Time samples are used to store time varying data for attributes. Okay. So different like an attribute will have different position at different times, different rotation at different times, and material properties like different sort of reflections and material shading properties at different times. So when an attribute is evaluated as a specific time code on a particular specific time code. Oh, 1 second is out the back. I'm excited about getting to the examples today because we have our notebook working for the render as well. And we have got some pretty amazing research papers to read. Video generation in robotics, prior work shows what hmm. Time samples are used to store, okay, we did this. When an attribute is evaluated at a specific time code, the value is linearly interpolated from the surrounding time samples, allowing for smooth animation playback. Got it. Okay. Cube dot get display dot color attribute dot get time samples. Uh-huh. Below is example of how we can get or set time samples in Python. First, we are getting time samples of the display color on cube prim. This method returns a vector of the time code ordinates at which time samples are authored for given attribute. Lastly, we're setting translation value of sphere at specific time code. This method sets the sample value of attribute at specific time code. Cube dot get display color attribute dot get time samples returns author time samples. Okay, cool. Lastly, we are setting translation value of sphere at a specific time code. This method, okay, returns author time samples. Cube. Okay, wait. I think he's here. Ooh. Yeah. 1 second. Let me put you back in the stream. Yeah.
That might be causing those issues.
Mhm.
Or
Yeah.
let me, I'm paying for cloud code, right? Let me pull that thing up.
Bro, do it after the stream.
Yeah, yeah. I was just gonna do it in background, anyways. So, where were we?
Yeah, we were just watching this. We did this, and then we're talking about time samples are used to store time varying data for attributes such as position, rotation, or material time properties. When an
Mm-hmm.
attribute is evaluated at specific time code, the value is linearly interpolated from the surrounding time samples. When an attribute is evaluated at a specific time code, the value is okay. So basically, if there are, let's say, 1, 2, 3, 4 as time codes, and we specifically stop the frame between 2 and 3, right? So the value is basically gonna be linearly interpolated. This is going to be the algorithm that's gonna be used for animation on the stage,
What does
scene
that mean?
description
Like
stage.
what does it mean in simpler way, simpler terms?
Wait, I understood that.
Linearly.
I think, let's say this is the frame, like this is the timeline, right?
Mm-hmm.
Let's say these are the frames, right?
Okay.
Okay. Now over here, one, fuck, bruh.
1, 2, 3, like an
Yeah,
array.
yeah. So basically, if they uh, ask us, 1 second, this is 2, this is 3, this is 4, whatever, right? And I specifically stop the like stop the frame in this part, right, in the middle. Let's say. So it's saying how is gonna like a prim gonna look like if a prim was a sphere in frame 2 and a square in
Mm-hmm.
frame 3, right? How is it
Mm-hmm.
gonna look like if I stop it right in the middle of these two frames?
Hmm.
It's gonna
So
look something like this because it is gonna be translating to, like, a sphere is gonna be translating from a sphere to a cube, right?
mm-hmm.
So
Mm-hmm.
the what this is basically saying, is when an attribute is evaluated at a specific time code. The
Hmm.
value is linearly interpolated from the surrounding time
Hmm.
samples. The surrounding
Hmm.
time samples over here, like
Oh.
this is the attribute value over here, and this is the attribute
Oh.
value over here.
Oh. Hmm.
So that is gonna be allowing for smooth animation playback. The animation playback that we are looking over there.
Hmm.
And I think we're gonna see some really good examples in our notebook once we start running these.
Hmm.
That's what I feel.
Makes sense. Makes sense. Hmm.
Nice. Okay. Now, let me. Below is an example of how we can get or set time samples in Python. First, we're getting the time samples of display color on a cube prim, right?
Hmm.
So that is done. This method returns a vector of time code ordinates. This method, okay, returns a time code ordinates at which the time samples are
Display
authored.
color.
Yeah, display color attribute. And then they're using get time samples function over here. So
Okay.
that's basically gonna return the time samples. It's gonna return a vector of time code ordinates at which time samples are authored for given attribute. Lastly, we are
Hmm.
setting a translation value of a sphere
Hmm.
at a specified time code. This method sets the time sample
Hmm.
value of the attribute at the specific time code. This method sets the time sample value of the attribute at a specific. Set the time sample value gf-vec3d. Okay, so this is gonna be RGB again, I think.
Hmm.
At a specific time code, sphere xform API dot transit. I think I'm gonna have to ask this explanation.
Hmm.
Guys, say hi in the chat. There are six guys, six people watching this.
So if Ishan Karango, if you are watching, please send a hi.
He's your buddy.
Yeah, he's my buddy. He's gonna be a millionaire soon. You like us.
Like, okay,
Same private jets. Same private jets.
same. Nice. Okay. This code shows the two sides of working with animation in OpenUSD, reading existing animation data and writing new animation data. Okay. Reading animation data, what it does, it asks the computer at which specific frames did someone change the color of this cube. Okay. The result, it returns a list of time codes, frame numbers. Dumb analogy. Imagine a flip book where only some pages have drawings on them. This command gives you a list of the number of pages where that actually have ink on them. Okay, got it, got it. So this is basically giving us the dictionary for
Mm-hmm.
uh, when the colors are actually visible, right?
Mm-hmm.
Okay. Writing animation data. This is how you tell the object where to be at a specific moment. So sphere xform dot API dot set translate the move command gfvec3d the destination. It tells the sphere to go to these coordinates. Gfvec. Okay, move. This is the vec3. This is the thing we were using to move over
Mm-hmm.
the x, y, or z axis for a whatever object.
Mm-hmm.
And then time equals to USD dot time code 30. USD dot time code 30. The appointment time. It says don't just move there now. Make sure you are at these coordinates exactly when the timeline hits the frame 30. Okay, got it. Oh, okay, okay, okay. And then, okay, I think I get what this code is doing a little bit. Okay, I think we can move to our notebook.
Mm-hmm.
Let's create a USD stage to serve, blah, 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 blah. Okay, let's see the magic over here now. Let's go. Oh, we could have just read this also. I think this is the same thing.
Mm-hmm.
Okay, let me run this.
Okay.
Import necessary modules, create a new USD stage, define a transform X form primitive, define a sphere primitive as child transform, yes. Define a blue cube as background prim, display assets. Okay, so this is our thing. Oh shit, that is awesome.
Damn. So this is on a time frame.
No, this is not this is we have not done the time frame stuff yet. We have
Mm-hmm.
just defined a new stage file called timesample code timesample.usda. File path is assets time code sample USDA. Stage is USD dot stage, create new stage like for the file path. So this file is used to create the new stage.
Mm-hmm.
And then we have defined a transform primitive at world. So remember how we were doing it in prim.
Yeah.
So we have just used the xform usdgm.xform API to define this stage.
Mm-hmm.
And then we define a sphere primitive as child of the transform at world sphere. So this is how we define the child. You know, sphere is usdgeom.sphere equals to usdgeom.sphere.define. It's gonna be stage, comma, world dot get path dot append path sphere. This is the typical syntax for defining us like an object as a primitive as a child of a stage. And then we define a blue cube as background prim. So this is the blue cube over here that we are seeing as the background prim. Box is
Mm-hmm.
usdgeom.cube, usdgeom.cube.define stage, comma world dot get path append backdrop. So this they are gonna use backdrop as its name. I think that this is because backdrop is something that is already defined in this usdgeom.cube API. Um, yeah, I'm still a little bit confused about how that API operates exactly because they just name stuff over here like backdrop and it just magically becomes like a background thing. I think
Hmm.
all of this is predefined in these APIs. We still need to look at those API docs, bro. USD Geom API docs. Bro, there was a list. The core schema for defining, interchanging. I don't know where the fuck. USD Geom and then Cube. Hmm. Xform. Define get schema. Static define get. Okay. Okay. So what over here? What's happening is they set it for one. So box dot get display color attribute. Set this to 0, 0, 1. Cube xform API equals to USD geom xform common API. What does this
Hmm.
mean?
Dude, that's just a wrapper. It wraps your box into the XFOAM API. I think
Okay.
yeah, it's a wrapper.
And this is, I think this is where we are defining.
So once you wrap the box in a wrapper, then you can translate it over an axis. That's how it does it. So XFORM, a common API, gives you the power to translate over an axis. That is one of the feature of the XFORM common API.
Mm-hmm.
It is usually used for transitions, as we do remember in our initial streams when we went through the
Mm-hmm.
API. It is usually used for geometric translation and all those kind of things.
Yeah, let me just be sure.
Hmm.
And oh my God. Mm-hmm. The code is essentially building a backdrop for your scene. You can think of it as a hanging large blue. Okay, we know this backdrop. Okay, painting it. Oh, this is just setting the color as RGB. So RGB, this is blue. Oh, okay, okay, okay. And then cube xform API equals to USD geom dot xform common API box. Where is that? Stretching it into a wall. Cube xform API dot set scale GF vec 3F plane. That take that cube and squash it. What the hell? By making it 5 units wide, the tall units point one thing, you have turned 3D block into a flat white panel as a piece of plywood. Okay. Pushing it back plane. Move this panel 2 units away from the camera. U move Z equals to. Oh, we can do all this shit as well. Just using this cube xform API dot set translate of GFX 3D.
Hmm.
Create a cube, paint it blue, flatten it into white wall, and slide it into the background at as a stage floor backdrop. I see. Okay. But what does this line mean then?
Which one?
Box. It specifically skipped over the box line. You created the backdrop wall.
Hmm.
USD geom.xform common API. This is the specific toolkit that OpenUSD provides. The assignment, you are wrapping the box in the toolkit. You use you can use simple commands on it. Why do we need this remote? Normally we are using blah 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 without remote control. To manually write out transformation by using XFORM common API, you unlock common easy buttons and translate. Okay. An easy to use interface so that you can move backdrop around. Oh, so this is the line basically responsible for us to be able to move this block around like this. Do you get
Hmm.
it?
Which line are we talking about?
This
This GF.
XFORM common API thing that it's using.
Yeah, and then it's
This is
gonna
the
it's.
line responsible for us to be able to move around this thing easily because look at this what it's saying.
Hmm.
Normally, moving things in OpenUSD is incredible, math heavy, and annoying. Without the remote control, you would have to manually write out transformation matrix, a big grid of numbers
Hmm.
that handle the math for you. Using the XFORM common API, you unlock the common easy button, set, translate, move, turn, stretch. The simple analogy, the universal remote. Imagine you just bought a complicated high-end TV. You could open the back and rewire the circuit board every time you want to change the volume. Instead, you buy a universal remote, XFORM common API, and point it at the TV. Now you can just do volume
Ah.
up, volume down, and all that shit. I see, I
Makes
see.
sense. Makes sense. So it's a wrapper, right? It wraps the prim. into that API so that we can have fun with it basically, right?
Exactly. Yeah.
You know, have you seen that video from SpaceX? Open it. Go to YouTube. I will show you right now.
Uh-huh.
Go to YouTube and type SpaceX and Elon Musk. I think yeah, go ahead. Yeah, no, go down, go down. Oh, wait, let me send you the link. I saw that video and Elon did use the same thing for SpaceX.
Like the X form API?
Yeah, I for sure. SpaceX. Wait,
Is this
SpaceX
the one?
Elon Musk. Wait, no. Yeah, this type the future of design. The future of design. Just search future of design is gonna show up. The future of design. This
This
one.
one.
Yeah, for this I think he has used OpenUSD.
Sort of 2D way. And we're trying to create these 3D objects using a variety of 2D tools. And it doesn't feel natural, it doesn't feel normal the way you should do things. So we started playing around with the idea and using a few of the things that are available out there, such as the Leap Motion and Siemens NX, which is what we used to design the rocket. And we wrote some code to integrate the two. And we started off with what you see here, which is
So he's not gonna show how he has used it, but he
of the
like the way he
the motion
showcases it,
engine.
right? Like the
And
moment.
and what I can do is I can go and grab it, and I can rotate it in multiple dimensions. And then what I can do is I can put another hand in there, and I can zoom, or I can zoom in and out on the wireframe. And then I can also translate it. So I can move it around the screen, and then zoom and translate. And this is what we started off with a few months ago.
And this is how I think he was able to render the whole thing out.
You can also spin it, and then catch it. So this is kind
What
of
do you think?
a fun way to interact
Yeah,
with
this is definitely the
what's
same
a
thing.
very complex model.
Right?
Yeah. But it's using hand gestures and motion sensors just to
Dude,
do
like
it.
he's Elon
Let's
Musk,
go from
so
this to
definitely
what
he
we're
won't be doing
sort of
simple
doing just
shit.
after the wireframe, which is to actually use a full 3D CAD model of the engine. So here what you're seeing is the actual interaction with the CAD software manipulating the real 3D model of the Merlin engine just using hand gestures. If you can just go in there and do what you need to do, just understanding the fundamentals of how the thing should work, as opposed to figure out how to make the computer make it work, then you can achieve a lot more in a lot shorter period of time. So then we went to a 3D projection. We started off with the kind of 3D projection that you're familiar with in the movies, where you use 3D glasses. We also did a freestanding glass projection.
Yeah, bro, I understood. It's pretty much the same idea of doing the XForm API, but yeah, they're just doing it at a very sophisticated high level.
Hmm.
Yeah. All right, let's move forward. Setting start and end time codes. Time code specifies an exact frame or moment in the animation timeline. It allows for precise control over time. Are you able to see or no?
Yeah, I'm able to see.
Okay, read this first example.
The time code specifies an exact frame or moment in the animation timeline. It allows for precise control over timing of change to properties, enabling smooth and accurate animation of the 3D objects. So a USD CPP, is it C++?
Yep, I think it's C++. plus plus. USD time code. A USD time code is therefore unitless generic time measurement that serves as the ordinate for the time sample data in USD file. USD stage defines the mapping of the time code unit like seconds and frames. What does that mean?
Mm-hmm.
Unitless,
Well,
okay. USD time code, therefore, generic time measurement that serves as the ordinate for time sample data in USD files, correct? USD stage defines the mapping of time codes to units like seconds and frames, defines the mapping of time codes. Units like seconds, okay. To set the stages, start time code and end time code metadata. Start time code and end time code metadata. Use start time code and set end time code methods. Okay, got it. So basically, we're gonna open a stage. We're gonna use the same USD stage dot open. We're gonna set the start and end time codes for the stage. Stage dot set start time code is 1 and the end time code is 60.
mm,
Export a new flattened layer for this example.
cool.
Okay,
Wait, I
let
will be
me.
back. Give me a minute. I will be back.
uh, I think some issue.
Boom, boom, boom. There we go. Yes, sir.
Oh, some guy in the chat has put something, bro, for us.
What?
OpenSwarm is an open source multi-agent AI team built on agency. Swarm was made open source, so you know. Let's see what this OpenSwarm thing is.
I think this is something that he might have created.
Multi-agent orchestrator. I think I've already heard about this.
Open Swarm? I have heard about Hermes.
Yeah, yeah, yeah. I think I've already heard about this.
Swarm.
An
Autonomous
AI,
AI team. Oh, autonomous AI team. Wait.
an AI army at your fingertips. Your free and open source mission control center for swarm of AI employees. Now in beta, try it free. Download for Mac. I think this is some open claw bullshit with agents.
Oh, openswarm.com. I was looking at the GitHub.
Just describe it. Open
Damn,
swarm.
bro. Cool UI. Cool UI. We should design something like this as well.
Bro, this is definitely Claude design. I'm
Yeah,
100% sure.
I
This
can,
is
dude.
Claude
The whole
design.
thing, dude. Even the logo is, I think, similar to Claude.
The whole aesthetic is Claude design, bro. This is
But
Claude
but it's
design.
not that bad, dude. It's not
Yeah,
that
yeah,
bad.
obviously it's not
It's
bad.
good.
Bro, that's what I was telling you like the other day. That everything is
Right,
gonna
and
look like the same
right.
thing
Let
now.
let me, dude. And anyways, this is an open source thing. So,
Yeah.
how many stars do we have? Oh, 420. So this is something new.
Yeah, today
Okay.
he said Sayandhar.
No, dude, but he's not the contributor.
I know, bro. He's just a guy who put it in chat.
No, no, I thought he was contributing over here, but I think he
No, he
was
was
saying
just
for.
okay, let it be. Let's focus on this.
Mm-hmm.
Got it. Open stage from starting point USD A. Set the start and end time codes. Okay. Export new flattened layer for this example. Stage dot export assets time code ex1 dot USDA. What does this mean? But let's run it first. True. Okay. Show USD. What does that do? Nothing. It's the same thing.
Wait, go up.
I think this is just.
Set. Okay, we are starting. Throw node the stage.
Let me read over here, bro. What is it trying to do? Open stage from starting point done. Set the stage. So we are just setting the time code at 1 for the stage. And stage. Okay. But okay. But what is happening over here? I'm not able to
Yeah,
understand it.
I'm also confused right now. Let's Gemini.
Okay. Setting the in and out points. Stage dot set start time code 1. Stage dot set end time code 60. Analogy. Think of this like start and end markers of the video. What it does is you're telling OpenUSD that this specific scene begins at frame 1 and ends at frame 60. Okay. Even if you have animation data at frame 500, a player like USD View will only play the loop between 1 and 60 because of these settings. It defines the active window of your scene. Exporting the final cut. The action. This saves you your work to a new file on your computer. Okay. The flattened layer means the export command creates what is called a flattened file. In OpenUSD, you often have many layers like transparent sheets stacked on top of each other. Flattening takes all those layers and bakes them into one single easy to read list. Okay. What does that mean?
Flattening. So flattening means basically turning a 2D array into a 1D array. That's what flattening means.
Okay.
Yeah. So if you have like three-dimensional array or four-dimensional array, then you can use flattening to convert it into a single array, so that it becomes really easy for us to understand. That's what basically it means. But uh, how does it tell the stage to run frame one and then save everything we have done into a single file called? Oh, okay, wait. It's saying that it's gonna save everything in a single file .usda. But set start time code one.
Okay, wait. Tell the stage to run from frame 1 to 60, then save everything we've done into a single clean file. Time code. But what's the point? Like, I'm not able to understand. Okay, how is it running from 1 to 60 in one block?
Yeah, that's what I'm also confused with. So since you have with when you open the new file and you have the playable files and
Anybody in the chat?
anyone? No.
Hmm.
Six, but it's moving, right? Like if you go down.
It's just this. Like, it's what we did
Okay,
over here.
leave it. But it is still moving on its own. So what if we run this code in our system? What happens?
Yeah, same thing. It's the same thing.
Wait, no, just leave it. Like this is not the code, right? Or
No, this
is
is the
this the
code.
code?
This is the code. Oh, this is the
Hmm.
same code that they ran.
It's gonna export and
They've
then
just put it in the top layer, top of the layer. I don't know what that means. Wait, let me ask a better model. Why are we storing it in the top layer? What's when does the frames run? Oh Lord. Bro, I hate fucking Mac.
Oh, you are just writing two numbers into the scene. You are not telling it to animate.
When you call stage dot set start time code 1, you're not telling it to animate, you're just writing two numbers into the scene. If anyone plays the scene, the valid timeline runs from 1 to 60. Okay. USD is built in layers. Think Photoshop layers, but for 3D scenes, you might have a base layer with geometry, another layer with materials, another with animation, all stacked into one stage. Start slash end time codes are stage metadata, not data on any specific object. They describe the whole composition by convention. USD writes that kind of global metadata into the root layer, the topmost one.
Hmm.
Okay. Okay. Is the OpenUSD file stamp start one and 60 onto stage metadata, export the results to a new file. Okay, so we're not playing anything over here. Got it.
Yeah. So it's
We're
but it
just
does say it will render from 1 to 60.
no, no,
But
no. It just says it that at frame from frame 1 to 60, if a red like if a software is trying to render it, so from
mm-hmm.
frames 1 to 60, you need to show this.
Hmm.
That's what it says, I think.
Hmm.
Okay, some complicated shit. Stage dot export. So this is just exporting the flattened layer of for this example in the top layer into a new file basically. So huh, display USD assets time code ex1.usd. Okay. Setting time samples for attributes. Time samples. Okay, let's read over here. Example 2. Come on, read it.
Example 2 time. The time sample represent a collection of attribute value at various points in time, allowing OpenUSD to interpolate between the values for animation purposes. When animating an attribute, you define a time code at which the value should be applied. These values are then interpolated between time samples to get the value that should be applied at the current code. To assign a value at time code, use the set method. Okay, oh, it's the same. We use the method as usual to assign a value. And if you want to set the size of cube to 1 at time code 1, oh, okay, okay. This is where we are going to render or animate something. Yes, there we go. So we have a cube size attribute, and then we are going to get the size of the attribute.
Mm-hmm.
And then at time 1, we are going to set the value 1, and at time 60, we are going to set the value 10.
Okay.
So as the frame moves by,
Mm-hmm.
it's gonna the size of the cube or the value that
Oh, okay, okay. So, okay, let me read that one more time. I got it. I understood this.
Hmm.
Time samples
What are
represent
the?
a collection of attribute values at various points in time, allowing OpenUSD to interpolate between them. So this is the animation process. When animating an attribute, you define a time code at which the value should be applied. Okay, so a time code at which the value should be applied. These values are then interpolated between the time samples to get the values that should be applied at the current time code. To assign a value at a particular time code, use the set method. Got it? Set takes two arguments, the time code and the value to assign. Got it? For example, if you want to set the size of the cube to 1 at the time code 1 and 10 at the time code 60, you would do get size of the attribute cube size attribute USD attribute cube dot prim dot get size attribute. Okay, set the size of the cube at time 1 equal to 1. So cube size attribute set time equal to 1 value equal to 1. Okay, so at frame 1 the value is going to be 1, at frame 60 the value is going to be at 10, right? USD will interpolate the values from the cube size attribute between the set time samples. Okay, let's create this sphere that moves up and down using XForm Common API. Got it. Okay, bro. I think now is something crazy is gonna happen.
Woo! And for the magic, time for the magic to happen.
Oh, animation. Hey.
Okay. Damn, bro. How? Wait, dude. This is some advanced shit. Go back to the basics, man. Go back to the basics, please.
No, no, I understood, bro. It's very easy.
Yeah.
Yeah, yeah. What's happening over
Hmm.
here is basically, so
Oh
did
no, I
you,
get it. Yeah, I can see it. That's how we are doing time one, time 20,
bro,
time
this is
45,
just,
time 50.
it's like very simple interpolation, bro. It's there's
Oh, okay. Yeah, I can see the axis. We
set
are doing it
translate.
on y-axis. We
Yeah,
are doing on the y-axis, right? Huh.
yeah.
Easy peasy.
At time 130, 45, 50, 60.
16.
So like, okay, at 1 it's starting from here to
Yeah.
uh 130, 45, 60, and then basically that's just giving us an illusion of the ball bouncing. It's not
Hmm.
actually
Makes
bouncing,
sense.
it's just present at that moment over here.
Hmm.
Simple. It's pretty simple if you think about it.
Hmm.
The code is easy. Code is very basic over here.
Hmm.
I'm
Hmm.
I think there should be like some sort of for loop or something that should,
I think as soon as we move ahead and go more deep into
yeah,
OpenUSD,
yeah.
we would be I think open to more complex. It's like a game. They're trying to
Mm,
teach us through step by step, and then they're gonna give us a big villain that we have to defeat a boss level
I
or
see.
something.
Oh, okay. So this was pretty easy. I'll just go through the code one more time just so we are sure that we didn't miss anything.
Hmm.
Um, so open stage from example one. We just opened the stage. We just again loaded a sphere that we had over there. Create clear any existing translation. So if translate attr is not equal to sphere dot get translate op get attribute translate. So this is just clearing any translation that was previously happening on that sphere.
Hmm. Makes sense.
And
Perfect.
then create xform API object for the sphere. So sphere xform API equals to USD geom xform common API sphere. Okay. And then set translation of sphere at time 1 and then time 30. So this is just setting the translate, and this is XYZ coordinates. And but one thing I didn't understand over here, so does this matter? Like over here they were doing time first and then value second, but over here they are doing value first and then time second.
It depends upon the
And this
API.
is a
Like how,
different function as well. This is set
yeah,
translate.
so
This
yeah,
is
so it
and this
depends
is
upon
set.
the so it depends upon the API, like what arguments is it gonna take. So for that, if the arguments are like, okay, first
Hmm.
you have to pass on the vector information and then you pass on the time information. So I think
Bro,
if you
this
go into,
API thing is really confusing. Like, I don't know where that documentation is exactly
dude, the
for.
documentation exists. It's over here, but it's like, okay, as we move through, we will eventually learn. Like you cannot like basically learn by heart anything.
Yeah, yeah, but for example, we are doing USD Geom, right? Or what?
Yeah, yeah. But anyways, it's like AI is gonna code us for that. So we just have to understand what it does.
Common API attributes is okay. Methods, got it. Okay, whatever. This is some insane shit.
Mm.
And this is how the USDA file looks like for this.
Hmm. Yeah. Okay. Let's go down.
Yeah, we're gonna read from here. So I think we can move to this. So time samples can be used for baked per frame animation and it's good for interchange. That is reproducible. However, time
However,
samples
time
are
samples are not a replacement for
for
animation
animation
curves.
curves. Curves.
Curves. Curves.
Because I think to perform like some sort of distortment in like a material, you can't just use time samples, right? Like you can use it
Hmm.
for like very basic stuff like bouncing a ball.
Hmm.
But if you wanna,
You have to use geometry, like some kind of parabolic equation or something
mm,
that will give you that curve, because then it's all about maths,
yeah,
right?
hmm,
Hyperbolic or sine wave or something. Like let's say you want to wave something like this, you can use sine wave function. That's gonna do that.
okay. And then for more complex animation, it is not recommended to define the animation using scripting, but rather than in digital content creation application like Houdini or stuff like that, I guess. So it is possible to set three time samples for different attributes. We can demonstrate this with the scale of the sphere. Okay. It is possible to set three time samples for different attributes. Okay. So that's what they did here. Or is it the
Hmm.
same thing?
Hmm.
I think it's the same thing, but let me check. Open stage from 2A, so it's just loading a stage, loading a sphere. If scale attr equals to scale sphere dot get scale op get attr scale dot attr clear. I think it's just clearing the scale, I guess. Sphere xform API equals to USD geom dot xform common API sphere. Okay. Again, they're just setting the sphere to be used as from the USDX form API. Set scale of the sphere at time one. So this, okay, one, three. At one, it's this. At 30, it's this again. Wait, at 1 and 30, it's the same. But at 45, the y-axis is reduced to point 0.2 and oh,
Dude,
wait.
it's basic. It's I think it's gonna like reduce the scale up and down accordingly.
Wait. Now this is for the attribute of the sphere. You see it's getting
Yeah,
compressed, and
yeah.
then you see there's like a thing happening with its geometry, like it's getting like an oval thing when it's going
But
up.
now I'm confused that
Oh
we are
wait, I
using.
understood, bro. I understood
But
completely
over
what's
here we are
happening.
using set scale. But then how is it translating? I'm confused with that. If we are
Bro,
using
look at
set scale,
this. It is possible to set time samples for different attributes. We can demonstrate this with the scale of the
no, I
sphere.
I know, but my question is, how are we uh, translating? Like, set scale is only to set the scale of that object, right? Like you can reduce and increase it, but now how are you translating on the axis?
I think that is because we are playing it from the previous. They have not, like, this is
Go
happening.
up, go up, go up,
What?
go up. Yeah, I want to take a look at the file. Okay. Oh yeah, yeah. We are
Bro,
playing
they're
it from the
using the
previous
same
one.
one. They're using the timecode
Yeah.
exe1 over here,
No,
I
no, no,
guess.
no, no, no.
Oh,
They're using
exe2a.
exe. So that is the export from this file, from
Wait,
the above
now
one.
I'm
Yeah,
confused.
yeah, yeah, yeah. Go to this. Look at the line 27 over here,
Oh yeah, see, they exported it to timecode exe2a.
and then they are using it again, and then they're rendering it.
Yes.
Okay.
So basically this USDA is already there when they're loading it over here. So
Hmm.
this is the bouncing is already happening. Now in this shell, they're just adding the elements to the scale as well. Like
Hmm.
the animation to the scale as well by adding this. So that is basically what it's doing is just, creating like a bouncy effect.
Bouncy effect. Yeah,
Yeah,
makes sense. Makes sense.
over
Perfect.
here.
Uh,
You see. I think I can do this. Wait, let me see if I can do this on my Mac. I think I can. If God allows.
why not? You have Cloud Core Pro is gonna allow you.
You the champ, right? You the champ. Show me. Where is this stage setting? README requirement security source. Is it in source? Nope. Hmm. What? Where is this? Timecode ex2b.usda. Okay, time for the truth. Let's see. What? File not found. Why? I don't know, bro. It's okay. Let it be. Why? But I understood how they're doing it now. Let's move on.
All right.
But where are we gonna move on, bro? We are done. Key
We are
takeaways.
done. Time for the quiz. Time for the quiz.
Wait. Let's read the key takeaways first.
To sum it up, the time code provides a unitless time ordinate scaled to real world time.
Okay,
While
wait. There's a guy in the chat. He's asking. He's here for the first time. Can you explain quickly what you are doing?
so
Do you want to explain or should I explain?
You can go ahead.
Okay. Shantanu, say hi again so that we know you're listening and we're not wasting our energy by explaining it again. Just say hi one
But
more time in the chat.
I think dude, we missed him. That's fine. Is anyone viewing us?
Bro, you're gonna lose your mind. You know how many people, like, I think today's stream was like the highest grossing stream. Like, three people are
How
still watching us.
okay.
At peak,
So
there were
can you
like 12 people watching
so
us.
if those three people can say hi, it would be really, great.
Oh,
Oh
yeah,
yeah,
there
dude.
they are
Oh
watching.
yeah, there he is. Yeah, there he is.
Nice.
Okay, okay. Let's
Okay,
go.
so
Let's
what
go.
we are, yeah, yeah, yeah. I'm gonna tell you guys everything. So we're trying to build a startup called World, where we are basically gonna be, so for robots, they have these policy models that they work on, they operate on. So what we are trying to do is improve those policy models by, you know, helping create digital twins for the environments that they're going to be training in and simulating the training required for them to perform the niche tasks that they're going to be assigned with. So once they are trained enough in this digital environment, they're gonna keep improving their tasks. So, like, for example, they're gonna improve their dexterity, they're gonna improve their, failure detection so that they know what strength to use to hold what object and how to keep it on a table, or, all sorts of stuff like that. So, what we are trying to do is we're just trying to create a dashboard that would basically provide the robotics teams who operate these policy models for their robots with a dashboard that is gonna have multiple agents run these physical AI workflows for them. So what these physical AI workflows do is they basically operate on five pillars over here. So first is the coverage gap analysis. So this basically tells us where the robot is failing, how is it failing, what scenario, and then second is scenario generation. So what scenarios should be generated synthetically so that the robot can complete its training and not fail in the real world. And then how do we evaluate those trainings is going to be the third pillar. And then when do we need to retrain? So is it going to be like a cron job? Like, do we need to retrain at the end of every week, or, after some sort of iteration? And then basically, how do we, amalgamate all these training learnings from the robots in a policy model and aggregate those in a compounding library. And so that those libraries can be used across all the policy models across all the robots. Um, so that's pretty much what we are trying to do over here. And then for that, we need to rely heavily on, NVIDIA's tech stack, which is Omniverse or Isaac Sim or Isaac Labs, which are just, some software that you use to simulate environments and to help robots train in those environments synthetically, so that they basically learn in those environments. And it just saves a lot of money, because right now there is like a lot of money and time involved in training these robots via maybe using imitation learning or teleoperation or all sorts of stuff like that. So to avoid that, we are moving towards the synthetic generation of these environments where the robots can train. And to do that, we would require a deep understanding of, how Isaac Sim works, how Isaac Lab works, what is NVIDIA Omniverse, what are the world foundational models, what is a world action model, and all sorts of stuff like that. And so for that, we basically took a step back and realized that it's really important for us to, get an understanding of
This
open scene description, which is this.
wait, it is not that.
Oh,
Like
no,
open
wait,
up
wait, wait.
the
Open USD. Wait.
yeah.
Oh, this, you know,
This. So this was developed by Pixar Animation Studios,
yeah,
and it gives you basically power to animate different kind of objects. So that's what we were trying to do. So sure, you can show some of the examples of what we have rendered till now on our Jupyter
notebook.
notebook.
Yeah.
Yeah. So these are some of the cool animations that you can do with this libraries over here.
Mm-hmm.
So you can make a ball bounce, you can make the ball have some fluid motion and all those things. To do that, we have you can use this OpenUSD library that is available in both Python and C++. Since Python is a really friendly language in like understanding and sorry, friendly syntax for that part. I think so you can do like basically different kind of shader movements. You can put any objects. So for example, over here we have a plate, and on that we have kept a ball or something kind of like that. So that ball can translate like on x-axis, y-axis. It can bounce up and down, or you can even change the color of the ball as well if you want. You can material it into different kind of wrappers or anything. If you look at our earliest streams that we did yesterday, we did take a look at the material API that helped us to try to like change the color of our objects or wrap them in a way. So these are some of the cool things that you can do with OpenUSD. And once you put all this all together, you can train a robot in a simulated environment. For example, like training a robot in a AI factory or a warehouse, where the robot doesn't know about anything about the warehouse, but eventually it's gonna know once it gets trained, and that thing can be replicated like to n number of people, buildings or infrastructure like that.
I'm just gonna use my Claude policy, like the project to just,
Like explain it to a 10-year
yeah,
old.
no, no, no. I have,
No, that's fine. You can do it. That's the best analogy, I would say. If you're able to explain it to a 10-year-old, oh yeah.
so I hope that answers a little bit of what we are doing. Shantanu Chandra 225.
And thanks for joining our stream.
Yes, sir.
Yes,
Very
sir.
motivating. This is very
Ye-
motivating.
Yep, yep.
Okay, so I think Claude has given us like a decent.
Damn, bro. Oh, Claude can do such cool animations.
Yeah, you didn't know.
No, bro. I'm a pro user of Claude Code on terminal. I don't like to use the web part, so I don't know. I still have to do the Claude design, but I have to work, and work.
Yeah. So this is like a decent explanation over here. Expressed in USD. So yeah, that's pretty much what we are trying to do over here. So I think we should move forward with the quiz now.
Yeah, dude. Let's focus on the quiz. It's
Oh, also,
116
oh
already,
fuck, it's
dude.
already 116.
Yeah, bro. It's already 116.
Oh my god, bro.
Do you have office tomorrow? Like,
Yep. I need to go to the office tomorrow.
oh, you have to. I
Yep.
thought it's hybrid, right? You were planning to go only on Tuesdays.
Yeah, but I need to go at least like a couple of days. So
Oh, okay, okay, all right.
yeah. God damn. Okay, let me quickly. Bro, this is shit, bro. Notebook LM does not capture the fucking thing
We can use Claude Code as well. Okay, the
for
quiz is
quiz.
ready.
No, this is the earlier one, like the older
Old
one.
one. I see.
Make a quiz. But I don't think Claude takes the. Oh, nice. Guys, if you're watching, spam highs in the chat. We're gonna shout out your name. Okay, bro, let's start this.
Okay, USD has a time code per equal to 30. An attribute has time sample authored. But dude, it doesn't know the pattern, the
No,
way.
no, no. This is really good. Like, this is better, bro. Like,
Okay.
because we had like options in Notebook LM, we are like trying to do the elimination thing and not.
No, but that's how that's how the pattern would be
Arey,
for the
bro, but
exam.
this is gonna be like more challenging for us to remember the concepts. And we're gonna do the Notebook LM one as well. Like, this is just 10
An
questions, right?
attribute has sample author 060. How many real world seconds does the animation span as? 30
Okay,
divide
wait.
by
A USD stage
60.
has time codes per second 30. Okay. An attribute has time samples authored at 0, 60, and 150.
3.
2, and then zero,
I think
1, 2, 3, 4, 5, 6, 5,
so. I
2,
would
and
say only
5.
3, right? 3 attribute time code is 0, 60, and 150, right? So it should be 30 divided by 60 divided by 30,
5
right?
seconds, bro.
60.
5 seconds. 5
2,
seconds.
yes, and 150 divided by 630.
5 seconds.
Okay, yeah,
I
five
think it's gonna be
five
5.
seconds. Yeah, 5.
Yes, sir.
5.
True or
True or
false?
false?
A time code
N-
in OpenUSD has units of
No.
seconds. False. An
An
attribute
attribute
has
has
time
time
samples. Okay,
samples
read.
at an attribute has time samples at time codes 10 and 30. The stage is queried at time code 20. What value is returned and how is it computed?
Interpolated. It is
How
gonna be
how is
linear
it?
interpolation between the attributes of time code 10 and time code 30.
Hmm. Rebel. Yes,
Yes.
sir. Linear interpolation.
Surrounding samples are time code 20, midway 10 and 30. Yes, sir.
Which two methods on USD state set the animation timeline boundaries?
Dot set.
Uh,
Wait. Fetch two methods on USD dot stage. Set the animation timeline
I think
boundaries. Yeah, set with
yeah, dot set
I
dot
think
set. No, it's something set something. It is like
set
complete
scale.
sets. No, no,
No,
no. It's move up, go up, go up, go up. It was in the first. Like go up, go more up, go more up.
this is what it is. After USD
No,
attributes set.
no, no. Go up, go up, go up. Is this the one? No, there is one more. Yeah, the set start time code. Is this the one? Set start time code. I think.
Oh,
Yeah.
for boundaries.
Yes. This is how you define the boundaries, right? Like start and the end of your time sample.
But that was not the question. I think animation timeline. Oh no, you're right. You're right.
Right?
Set start time code and set end time code. You're right.
Yeah.
Yes, sir.
Yes, sir.
Set start time
What
code and
does
set
the
end.
following line return?
Cube dot get display color
Uh,
attribute. Wait.
it
Dot get
returns a
time sample.
list. I think it returns a list of time samples. Wait,
Get
does it
display.
return a list?
Wait. Dot get color. Get display color attribute.
Yeah, it returns a list of time samples. I think so. Yeah, it returns a list of time samples.
List of time samples, but also I think it returns a list of time code with the color associated at that time code. I think.
No, attribute associated at the time code, not the color.
Color attribute, bro. That it says get
Yeah,
display color
so
attribute. Color
so I'm
attribute.
saying the attribute values, and so it's a key value pair. Remember, it's a key
Yeah,
value
yeah.
pair.
So the
So
value is
key
gonna be
and
the
the value.
color.
No, I think the value can be anything, RGB value, right? So it's gonna be some numeric value.
Oh, yes. Yes. Yes.
It's gonna be
RGB.
yeah.
Let's see what this is. A vector list. Yes, you're right. Time samples are authored for that.
By
It returns the time code themselves, not the value of those time codes. Just the time code.
time code. So no values, only time code. So if I think
Vector list of
makes
time
sense.
code ordinates at which time
Okay.
samples are authored. Okay.
So rather than returning the color, it's only gonna return the time code samples. Yeah, I was correct. In the example below, how many samples are authored on X form operation translate? What value is returned at time code 37.5? Go down. What value is returned, dude? This is like
Minus, okay, 0 minus point 4.75 comma 0. Yep. Minus 4.75, I think, over here between 30 and 4. Oh, no, no, no,
minus.
wait.
I don't know how
Uh,
are you doing the maths,
oh, yeah,
but
minus 4.75. Yes. In the
okay.
example, how many time samples are authored on X form translate and what, how many time samples, right? One, two, three, four, five. Five time samples. And then this is gonna be minus 4.75. Oh, yes, sir.
GM.
I am right.
Okay.
37.5. And I think five time
Mm,
samples. Yes. Bro,
mm.
linear interpolation.
So what did you do? So you divided
Basically,
37.5 divided by
no, not 37.5, bro. I
oh
basically did
oh so you,
the
okay.
middle, because it is the middle value between 30 and 45. I wanted to get the middle value between minus 4.5 and minus 5.
But this is just like a ballpark number, dude. Like I was looking for the maths.
Yeah, this is not a ballpark number, bro. Minus 4.5 plus 5 divided by 2.
Plus 5 divided by 2. Okay, linear. Oh, divide by 2. Why?
Linear, bro, linear.
Oh, I see.
Interpolation is like they do like the equal weightage of the attributes.
Okay. Mike, makes sense. Makes sense.
That is simple math.
Divide by 2.
You're just adding 4.5 plus 5, which is 9.5, divided by 2, it's gonna be 4.75.
Hmm. Makes sense.
Okay, what is the
What is
time
the time
codes?
code per seconds defined and which layer value is used to interpret the codes
Root,
for a stage?
root layer.
Root. Okay, root. I don't know this. I'm not able to recall this.
The time codes per second is defined in the stage, and which layer's value is used to interpret the time codes for a stage is the root layer. Defined on a layer. Okay, and yes, the root layer.
Only back in right?
Okay. Oh,
Okay, I'm back.
holy.
Yes, sir. So time code per second is a metadata defined on layer. Okay, it's a metadata. The article specifies that the time code ordinate of all time samples are scaled to seconds based on the value defined in the root layer. It's a metadata. Yes. The article notes that the samples are good for interchange and is reproducible, but are not a replacement for animation curve. Why does this distinction matter? Because we are not able to animate curves.
Hmm. Because we need to use digital content creation tools for intricate animations.
Okay, now it's gonna for an instructs bin picking scenario. You need to record now
Wait. Time samples are baked per
per
frame.
frame.
Discrete
Discrete
values will,
values.
yes, linear interpolation between them. They reproduce identical across applications, great for interchange. But they cannot express curve types, Bezier, Hermite, ease in and out, tangent
Oh,
control. Oh, this was not in the
makes.
this was not in the article.
Yeah, this is some additional information we get. Bezier, Hermite, ease in, ease out. These are like front end animation things, dude. Ease in, ease out is a front end Tailwind CSS library. I think front end developers is anyone is over here
CAD, bro,
in the
CAD.
chat. CAD. No,
Yeah,
like I was talking
any
about ease in, ease
developers in the
out.
chat? I think there should be some developers in the chat.
Who is
Say
visible?
hi. Oh, okay. So Shantanu is asking, okay, so USD you said, how will you scale from that bouncing ball simulation to actual real working robots
Oh,
in
like is this
factory?
part time or okay? He's asking if we are doing it part time.
Are you also taking AI help? Yeah, bro, we are depending on
Dude,
AI with our
yeah,
lives.
without AI, we have a lot of subscription, dude. We are completely surrounded by AI subscriptions
Yeah,
now.
that's how you should be, bro. Like, if you're gonna
Yeah,
be a psychopath and do everything on your own, just forget
yeah.
it. You're not gonna be able to compete with anybody in this in
AI
US.
all the time in
Yeah, at
US,
least in US. I don't know about India and
dude.
shit.
Yeah.
Okay. Uh, Bezier curves, Hermite splines, spleens or spline. I don't know what that is. Ease in, ease out.
And
Yeah.
dude, wait. We did not answer his questions properly. So he also said that how will you scale from that bouncing ball simulation to actual real working robots in factory?
Okay, so basically the thing that you see over here, the code, it generates a USDF file. This USDF file is an environment or a stage that gets rendered. So once we are, good enough at generating these USDF files, what our aim would be to basically generate a whole environment based on some either input like photos
let's
or
say let
videos.
let's say we you want to design a warehouse or a
Yeah.
room, right? So this is like basic building blocks. Like first we are trying to see how you can uh, render a ball. Then we are gonna learn how to render a block, and then we are gonna put together all the things to render a big room or something eventually. But yeah, I think Shaurya is gonna show you the vision that NVIDIA Omniverse has.
Bro, that uh
Wait, yeah, like that. Oh wait, is that the one? I think
no, bro, I don't know, it's some like I don't know
you can.
why
I
they.
think we can use. We can show the asset packs as well. Asset packs, dude. Why the hell are you at the forum? Yeah.
Okay, so these are the asset packs. So
So
the
yeah, this is
USDF
like
file that we are showing over here is, so these USDF files come as a pack from these assets, and we are going to be able to render these environments completely if we
like
download these.
yeah, and as you can see, the size of those packages is like 22 gigs, 18 gigs, and when you
Yeah.
scale it to like a warehouse that is like 1,000 acres or something, and you have a lot of robots running, you need a lot of compute to render those things and eventually train your robots into that environment. So it's a long shot goal that eventually robots are going to take over our jobs. And so these are like the building blocks, like how would I say, is basically the industrial revolution, but not for industries but for robots.
Yeah. Okay. Next question. For an Instructs bin picking scenario, do you want to read this or?
Yeah, sure. For an instructs bin picking scenario, you need to record a robot's joint trajectory over 4 second pick attempt at 60 hertz. So it can be replayed deterministically in the evaluation. What do you set it for? Time code per second, start time code, end time code, and how many samples per joint attribute?
4 second pick attempt at 60 hertz. So at 60 hertz is gonna be 1 by 60, which is gonna be what?
Zero point 0.016.
Okay. How did you calculate that fast, bro?
Calculator, bro. AI.
Okay.
Calculator.
And yeah, okay. So I think time codes per second would be 4 divided by 0.016, which is gonna be 100 divided by 4, 25. So time codes per second would be 25. And then start time code is going to be
Wait, what did
um
you said? 4 divided by 0.016.
yeah.
It's going to be 250. It's not 0.16, it's
Oh,
0.016.
250. 250,
Yeah,
okay.
yeah.
250, okay. Time codes per se.
Mm.
I think I might be like wildly wrong, but I think that's what it should be.
So what do you so what do you set it for time code per second?
I
So you're
think
saying what is the
250.
answer? 250. So 4 seconds per attempt at 60 hertz, 1 by 60, and then we divide 4. Okay. Yeah, I think 250 could be an answer. But time code per second. No, no, wait. We should multiply it, right?
4 to
We should multiply it rather than dividing it. It's gonna be
go
0.064.
6 to 40. I think time codes per second is gonna be 240.
So over a 4 second pick attempt at 60 hertz, how it can be replayed deterministically in an evaluation. Hmm.
And what is start time code and end time code over here?
Start would be over a 4 second pick attempt at 60 hertz. The start would be should be at zero. No,
Hmm.
you need to record or at zero, and then end would be 60 hertz replayed in evaluation.
Let's see what the
But
answer
first,
is, bro.
wait. Okay. You said 240, right? So end could be 240 and then 60 hertz. Wait, six. What is 60? So how 7 hertz was 143 milliseconds, right? What was the calculation for that? Do you remember?
1 by 7.
1 by 7. So you're gonna do 1 by 60. So it's gonna give you 16 seconds, right? 16 milliseconds,
Probably. Yeah.
right? So we have 16 milliseconds, and if we convert it into divide by what is how much is 1 millisecond in a second?
Bro, just do 4 divided by 1 by 60, which is gonna be 4 into 60.
Okay.
I think your answer is time codes per second should be 240, and I don't know about the start time and end time code
No, that's
because
what I'm trying to calculate since you have figured out time code per second, right? So we can do the maths 4 seconds per pick attempt at 60 hertz.
but that
So
doesn't depend on
no, 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 no. At 60 hertz, you know what that means? 60 hertz is the whole cycle, right? So if 7 hertz is 143 milliseconds, then 60 hertz is 1 divided by 60, right? So it's like 16 milliseconds, right?
Oh,
So
wait. Time codes per second would be 240. Start time code would be 1. End time code would be 240. That's what I think. And how many time samples per joint attribute? Um,
no, dude,
how
I
m-
don't think end time code should be 240.
time codes per second. Oh yeah, you're right. Wait, no. Time codes per bro. Let's reveal the answer. Let me see.
60, it's 60, dude. Wait. End time code was correct. 240. 4 seconds into
240.
60.
Yeah.
So, but how did The 60 came. One time sample
60
per frame
hertz.
per. Hmm.
One time sample per frame per joint is equal to 241 samples, inclusive of both endpoints, or 240 if treating as open-ended. The key point, keep time codes per second aligned with your sensor control rates, so time codes map 1 is to 1 with frames, easier reproducibility, no rounding in benchmarks. I see. This is, bro, I think we should use Claude. This is better.
Okay.
This is better
But then
for,
we would provide him with all the information, the guide that we did provided it to Notebook LM.
bro,
Dude, I
that shit was shit. It was shit, bro. In Notebook LM was shit. It didn't
no,
get
but the thing
anything.
is, we are preparing for OpenUSD certification, right? So
You just want more options, right?
I the thing is, dude, if we are preparing for
You want
exams,
MCQs, right?
we
You want MCQs, right?
no, my goal is to, because since we are preparing for an exam, we have to do it in a certain manner that they have provided it,
But
right? So that
bro, listen, the questions in Notebook LM were shit. Like,
well, that's what I'm saying. Just upload the exam guide over here as well.
oh yeah, that I'm gonna do. I'm gonna create
That's
like
what
a for
I don't
tomorrow's
have any
stream.
yeah, yeah, I
I'm
don't have
gonna
any
do like
problem
a
with
complete, yeah, yeah,
Cloud
yeah.
Code, dude. I'm a advocate of Cloud Code, dude. I would suggest anyone to use if they are trying to learn coding or anything, any technical skill that they want to develop. Definitely go for Cloud Code, dude. That is the best CEO, software engineer, principal engineer that exists right now, dude. I have upgraded my plan from 100 to 200 for that only. Like Cloud Code is
Mm-hmm. Yeah.
badass. SaaS subscriptions. Two of your evaluation scenario were author time code per second 20 legacy film and the time code per second 120 high rates regression test runner queries both at 1.5 second. Dude, this is some complicated shit. Reveal the answer.
Mm-hmm. Mm-hmm. Two of your evaluation scenarios were authored at time codes per second equal to 24. Okay. Bro, wait, I didn't understand this completely as well.
Yeah, so I was gonna say like copy both of them and then
Mm-hmm.
dude wait before we go in more deep, look at the time.
Yeah, I think we're just gonna read this one, reveal this,
Yeah,
and just stop after that,
yeah,
bro.
yeah.
Two of your
Because we will
evaluation
keep going
scenarios
on.
were, yeah, authored at time codes per second, 24 legacy film convention from vendor asset, and time codes per second, 120 high rate sensor capture, a regression test runner queries. Wait, two of your evaluation scenarios were authored at time codes per second, 24 legacy film convention, 120 high rate sensor capture, a regression test runner queries, both 1.5 seconds in. 1.5. Okay, so 24 plus 12, 36 seconds. I think 36 and 180. Answer should be 36 and 180.
Revel, revel,
Reveal, bro.
reveal, reveal, reveal,
And
revel,
what's the
reveal.
operational risk if your test harness ignores this metadata? The operational risk would be, I don't know.
Revel, reveal.
Yes, sir, 36 and 180. I was right.
Time code 36, 1.5 seconds, 24. So
Some quick
related to
math.
24.
Quick math. And exactly the kind of silent benchmark drift the okay whatever annoying audit traceability for pattern 19 lessons the runner queries in seconds never in raw time codes and reads
Dude,
time
what
codes.
patent thing?
It's because
This
I
still.
have it in the yeah bro, but we are making progress bro, like
Yeah, bro. I'm not.
another thing.
I'm not disagreeing, bro. Day
It's
one, you
one
know,
day,
it's
one day at
day
a time.
one.
One day at
One
a
day at a
time.
time, day one, Amazon mentality. Jeff Bezos.
Jeff Bezos.
Day one, brother. It's always day one.
Always day one. Alright, I think
All
only
right.
one guy is watching us now. Um,
I think,
it was a successful stream again.
yep.
And we
And
are,
thanks
this
for
is
the
like a,
supporters. Thanks for the supporters.
yeah, and we have like breaking our own record. Like we are breaking our records every day, you know. I think what are the number of views today? Let me check. 97 views.
Oh my god. Oh my
All
god.
time high. All
Holy
time high.
shit. Woo! Let's go.
Let's go, gang. Let's go.
All right. All right. Time to say good night and goodbye to our
All right,
followers
fellas.
and supporters. See you tomorrow, guys. Same
Later,
time.
gator. End
Later,
stream.
gators.
2 hours.
Bye.
Done. भाई देख भैंचोद आज कितने व्यूज आए हैं